everyone, and welcome to our virtual Lunch and Learn today. We'll be talking about Zebra label development and Logix integration. My name is Rachel Green, and I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today will be Kevin Schwarz, Integration Engineer out of our Madison Heights, Michigan location. Out in the comments section, ready to answer your questions, is Michael McCarty, Integration Engineer also out of Madison Heights. We'll also have a Q&A portion at the end for Kevin to answer your questions in more depth. We'll be getting started shortly. We'd like to allow a few minutes here at the beginning for folks to join us. Welcome, Terry and Tom. Thanks for coming. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just coming in, welcome to our virtual Lunch and Learn today, Zebra label development and Logix integration. Let us know where you're joining us from in the comments section. I see a lot of Ohio and Michigan so far. We'll be looking for your questions as you have them in the comments while our presenter, Kevin, gives an in-depth overview of the Zebra NetworkConnect system, as well as a live demonstration highlighting best practices for label design and Logix integration. Our specialist, Michael McCarty, is ready to answer your questions in the comment section as we go along, and we'll also have a Q&A segment at the end of Kevin's presentation. If you'd like to reach out afterward or if you have further questions, you can send us an email at macamaclive@macamac.com. Be sure to let us know which session you attended so we can direct your questions to the presenter. We'll also have the email address on the screen for you at the end of the presentation as well. Welcome, Justin and Sarah. Thanks for joining. Hi, Jody. All right, Kevin, it looks like we have a number of viewers with us now, so I will pass it over to you.
All righty. Thank you, Rachel. All right. Good afternoon, everybody. So as Rachel said, we're going to be covering label development and Logix integration for Zebra printer and highlighting the NetworkConnect line of printers and products from Zebra Technologies. So let's dive in. So we'll start here with what is NetworkConnect. So NetworkConnect, in the case of printers, is a specialized firmware specifically for Zebra printers, and what it enables is Ethernet IP communications for Logix controllers, so that you can use your Ethernet printer as an I/O device in your controller organizer and under your device tree with your Logix processors. Now, important thing to note: this is only for the compact Logix and the control Logix line of processors. For micro Logix, you will still have to communicate over serial. So we're just going to focus today on the 5000 series of processors, being the compact Logix and control Logix. But anyway, and like I was saying, it allows for a device or allows for a add-on profile for Studio 5000. You can add it to your device tree just like you would any other I/O module. So why do we want to use it? So first and foremost, there's a huge cost savings associated with using this NetworkConnect firmware, as well as it simplifies your architecture when you're deploying it in the field. So where you see your cost savings is that the old way of doing old way of communicating from a printer to a PLC, you had to have a third-party module, which would run you in the neighborhood of $500 to $1,000, and you also had to have the programming costs associated with it. So it might have required third-party software. It might have required a couple hours of configuration and mapping within the I/O module itself, or not the I/O, but the gateway module itself. And then it would also require some PLC logic to be developed in addition to that. Now, the other way of being able to communicate with these in the past is that you would write your own sockets going from the PLC to the printer via Ethernet. And that too would also require hours of programming, additional logic to be developed, and ultimately a lot of time and energy being put and invested into getting your PLC to print from, or your printer to print from the PLC. So with NetworkConnect, we now can go straight from the PLC to the printer without using any socket communications, directly over Ethernet IP. The printer has an AOP that can install into your Studio 5000, so you can add it just as you would any other I/O module, such as an I/O block or really anything that you would have. And with going directly to the PLC, you can get rid of that third-party gateway, so there's a couple $100 in savings there, and as well as you can eliminate any third-party software that you would need to program that gateway and send data back and forth between the printer and the PLC. So how does it work? The printer runs on, or basically within the printer, you can actually store pre-designed template files, or you actually can send whole strings of ZPL data. But for the most common way that we do it is we send a pre-designed template file, which can be generated from Zebra Designer 3, which is a free software from Zebra's website, or that you can get from Zebra's website. This template file contains a combination of fixed and variable fields. So these fixed fields would be the fields that would stay the same regardless of what the PLC input is writing to. And so that would be like in this case, or in this design that we have here, we've got our company name, we've got our logo, as well as some other fixed things that allow us to that wouldn't be changing label to label. Variable fields are going to be what your PLC would write to. So these are going to be, let's say you had a model number that the PLC was populating, or your serial number, UPC code, date code, whatever it be, these would be what the PLC are writing to. And so the way it works is when it goes to print, the PLC calls up a template file. That template file contains both the fixed and variable fields in the format that you want it to be. So everything is arranged kind of in the template file so that what you're seeing is, and where basically everything's going to print where it's supposed to print on the label. It will dump whatever information you want it to into those predefined fields and then send it out for it to be printed. So when it's printing, it for the variable fields at least, there's 5 that are native on the AOP. Now you can get more variable fields than that if you need to. There's a parser data field for additional data. Or if you wanted to send the entire ZPL file rather than using a predefined template, you could also send the entire ZPL file via this parser data field. And again, that's just an extra space to be able to write to the PLC, or write to the printer from the PLC. So, which printers are compatible? So all of our LinkOS printers, which are going to be your modern ZD and ZT printers, as well as some of our mobile printers, which are our QLN series. So specifically the QLN 200, 300, and 400. And those are only compatible with the mobile Ethernet cradle. But anything with an internal Ethernet server that runs LinkOS is going to be compatible with this firmware. Our most common printers that we see are going to be the ZD400 desktop series and the ZT400 industrial series. The ZD400 desktop is a compact desktop printer that replaced the popular GX and GK lines that you probably have a lot of in your facility. If not, the ZD400s you probably also have in your facility as well. The ZT400 replaced your popular ZM and XI4 style printers. Those would be your big metal case printers that have high print capacity and so on and so forth. So other models include your ZD500, 600s, and then ZT200s, 500s, 600s as well. So, and we have a variety of accessories that go with these printers that can allow for standard peel, tear off, whatever type of attachment you need for these printers, we can also get. So for the software requirements, for this one, the NetworkConnect AOP actually installs with later versions of Logix. So I believe version 30 and up of Logix actually installs with the AOP already in it. However, if you're running an earlier version of Logix, you can download the NetworkConnect AOP from the link below, which we have in a QR code here. You can scan with your phone, or in the comments section, we're going to post all of these links that I have coming up here, so you can come back and reference them at any point in time. So the NetworkConnect AOP allows you to obviously install the printer into Studio 5000 and allows you to select it for your project and create it and assign it a printer just as you would any I/O block or anything that you're adding to your Studio 5000 project. You are also going to need Studio 5000. We recommend version 24 and up. Now, if you need more information on Studio 5000 or would like to obtain a copy of it, we recommend that you reach out to your local Rockwell distributor and ask for some more information on that. And then Zebra Designer 3 is a free software. You can get the Essentials version of it, which is free. There are other versions of it that you can get. They're not needed to develop the template file for the ZPL aspect, or not the ZPL, but the NetworkConnect aspect of it. However, if you are printing from, let's say, SAP or an XML file of some sort, then you might need other versions of Zebra Designer. But for this demo, you can use Zebra Designer 3 Essentials, which is free and available from Zebra's website. Again, we're going to post all these links in our comments section, so you can go back and select these at any point in time. So, some other helpful information. We have our NetworkConnect Developer Guide, which, again, you can scan the QR code below it and pull it up on your phone, or you can go back, again, with the comments section and click the link and it'll take you to that website. So the NetworkConnect Developer Guide walks through how to use NetworkConnect on your, or with your PLC and with your printer. The ZPL Developer Guide allows you to insert customer, or let's say custom commands if you're not familiar with ZPL programming. And then the Intro to Logix Lunch and Learn, if you are not familiar with Studio 5000, I highly recommend that you go back and watch this video. This was a video that we posted on an earlier Lunch and Learn call earlier this year that covers project development and even some I/O development or logic development with Studio 5000. So highly recommend that if you're not familiar with Studio 5000. All of these links are going to be in the comment section that I've said a couple of times now. So please reference those at any point in time. Feel free to come back and watch this video again and reference those links and get the information that you need. So with that, let's get started on label design. So this here is what Zebra Designer Essentials looks like. Now this is the design software for your label, and this was what allows you to lay out and design kind of how you want your label to look and feel. So we're just going to simply go create new label. Now this is the latest version here. If you have an earlier version, I highly recommend that you update to the latest version. There are some bug fixes that allow, or that I guess remove the need to go back and modify the ZPL code once you generate the file from earlier versions. So I highly recommend getting the latest version. Again, it's available on Zebra's website for free. I have a printer that has already been predefined here from an earlier project. So I'm going to select this. If you needed to define a new printer, you simply go into the printer properties and set, your print width, label size, that kind of information within the printer's property field and continue forward here. But for the purposes of this demo, we're going to say, or continue with my existing printer. We're going to print a roll of labels. So we'll just thumb through this and we'll say, okay. For the portrait versus landscape mode, I want my labels to print side to side, so normal portrait mode. If you were printing something that you wanted to print lengthwise instead of widthwise, then you'd simply use landscape. And then this is where you define the actual size of your labels. So in this case, I have a 4-inch by 1-inch label. So I have that defined here. And for margins, I'm not going to include any areas that I don't want printed. So I'm just going to leave these at 0. If you wanted to, you can play around with them. But for the case of this demo, we're going to leave them at 0. All right, and we'll click finish, and that'll populate our label design here. So starting with fixed text, let's say we wanted to have a fixed text field across the top here with our company name. So I'm going to say we're going to drag this this text field over here, and we're going to drag it across the top where the relative area where we want it. We can move this around however we want, as you can see here, drag and drop. Now, if we want to edit the text inside of it, we come over here to the right side here, and I can type in whatever I want. So in this case, I'm going to say McNaughton-McKay. Okay. And we're going to drag this around wherever we want. I want it to be roughly centered. You can see up at the top over here, there's a ruler, and you can kind of see where, highlighted in blue, where it lies, so you can adjust it so that it's somewhat centered. Drag it over. And then if we wanted to add a couple more fields, we can add a couple more over to the side here. So for these, I'm just going to say model number and serial number just to keep it basic. Now, if we wanted these fields to line up, we can move them however we want. You'll see that there are some alignment guides that pop up, so I can get them to actually align. As you saw there on the left hand side there was a red alignment bar that popped up showing that I'm snapped over to that position, or where this one starts at least. So I'm going to leave that like that. I'm actually going to drag this guy down a little bit. And then, so that includes what I want for variable text, or for fixed text, sorry. Now what I'm going to do is I'm going to put my variable text in. So similarly, what we're going to do is we're going to go over to the text field, and we are going to drag a new text field into next to where we have our model number. Now, you can align it directly in line so that we can see the alignment guides pop up. This way we know that our text is in line. And we're going to change this to be, actually we're going to change this to be a variable keyboard input. Now, variable keyboard input, it's going to basically ask for data before it prints. And so this is its way of basically prompting the PLC to dump data into that string. So, and the Zebra Designer software creates labels in the order that you create these variable text fields. So the first variable text field that you create is going to be the first variable text field in your AOP. So that's something to take note of. So if you're trying to order these, you want to start with this. If you're trying to figure out what order they're going to be written to, it's going to be written to in the order that you created them. So for the initial value, we're going to put, I'm going to use this ZT410. But you would put whatever you want the maximum length of your string to be that's coming from the PLC. This way you can sit there and play with the, I click enter. You can play with the sizing and everything and the position of your templates, so that you can get the positioning of your text according to what you need it to be at. Since ZT410 is relatively small, I'm good with it, but let's say you had a really long string and you want to adjust the font size or the location or how it's centered, then you'd be able to do that. And for the serial number, I'm going to do basically the same thing. But I am going to count backwards from, or actually count forward from 1. So we're going to go variable keyboard input. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We'll click out. Now we see that we've got a 10-digit serial number across the bottom. I'm good with all of this information here. So we're going to click out of it. Now, if we wanted to add a barcode, we can create, you simply just grab the barcode tool, drag it over, create what you're looking for. Now this defaults to a code 128 barcode. If you wanted UPC, you can change it however you want. That's done here in the barcode tab over here on the right-hand side. Barcode type, you can drop down and change it. So let's say I wanted it to be code 39. I could have it as that. I could have it as UPC down here at the bottom, so UPCA. If you wanted it to be a 2D matrix, you could have a data matrix. In this case, it's really small because it's at 5 mils. You would increase the size of this to be 15 mils, so that this is something that you actually can kind of see with your eye. And you can see that. For this demo, we're going to go back to a code 128. I'm going to do this back down to, change it to 7 mils, just so that our width is good. And our height, we don't need it to be 3/4 of an inch. We need it more like that. So that concludes that. Now, if we go back over to the source tab, right now it's at fixed data. But let's say we want it to be variable. We can have it set it as variable keyboard input. for the barcode type or the barcode field, initial value field, what we're going to do is I'm just going to do the model number and then a hyphen and then the serial numbers. So we're going to say ZT410 hyphen 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And again, this is just so that we can see the size of the barcode and where we want to position it. So as you can see, it did add some length. The other one cut off about right here. So we added some length to it, and this is why we wanted to be able to play around with it and get your string size correct here so that your barcode length is correct when you're designing your label. So we're going to position this right about there. And we're going to add one more thing, and that's going to be a picture. And you can play with the size of it, as you can see. Drag and drop however big you want it to be. Now I want it to be pretty square. If you wanted to get really specific in terms of how to get it square, you can hold the shift key down and get it perfectly square. And I'm just going to select our Mac and Mac logo, and we're going to get this in alignment with where we want it to be. Now, for the picture format types, it'll allow either a JPEG or a PNG image, depending on which one your current format is in. That's what's accepted in the Zebra Designer, and that's what the printer will accept. You can store images into the printer, and instead of having them in your template file, and then just basically have the template file recall that image if you wanted to. But for this demo, we're not going to do that. You may have noticed when we created these, or the date and the text fields, that there were other options over here for current date, current time, and then counter. The printer actually has a real-time clock installed on it, as well as a counter or a sequence counter every single time that you print. And these fields here allow for you to recall or access that real-time clock and recall. So if you wanted to generate a date code or something like that, you could. Same with time, and counter would be basically the sequence number or the number that you printed off that day. We're going to leave those alone for now. We're not going to go too far into those with it. So we're just going to delete our text field here, and we're going to roll with this. So now if we wanted to print this and kind of get a demo view of how it looks, we would just click print. It's going to open up another menu here. Kind of gives, again, a print overview of what we're going for. We see our variable text fields here. What our values are according. This is what it's going to print based on the initial value that we gave it, not what the PLC is writing to. So this is just a demo print. And we'll click print. It spat out a label. And what the label looks like is, all right, let me pull it up here. This is what the label that it spat out is. So as we can see, it's pretty much exactly what we're looking for. So we're happy with this template file. What we're going to do is we're going to save this as, save it as a project file first. So I'm going to call this here, let's call it Zebra VLL test. And we'll call it Zebra VLL. That works. So we'll click save. And now we have this all saved here. So now we're ready to store it to the printer. One thing I want to touch on here is I'm actually connected to my printer via USB, and I'm actually connected via Ethernet to my Logix, which we'll demo here in a minute. You can connect via Ethernet to your printer. I'm just not currently. You can download fonts and formats via this utility here, the Zebra Designer 3, or you actually can generate a ZPL file and then download it via Zebra Setup Utilities or via, there's a web page that's embedded in the printer. So you can go to the IP address of the printer in a web browser and actually install the file that way. For this, we're just going to say we're good here. I'm connected via USB, so it'll automatically store to where I need it to go. So now we're going to go file, and then store. What I want to check is that we want to be in the internal flash. Now, you have option of DRAM, which would be user writable RAM. That would be volatile memory. So if you power cycle the printer, you're going to lose whatever format you had in there. Now, versus internal flash is going to be the EEPROM. And that will be a permanent file. So you don't have to worry about losing it after a power cycle. So I'm going to say internal flash for this demo. If you prefer RAM, you can select RAM. But for this demo, we're going to do internal flash. Now we're just going to say store to printer. And it's stored. So on your printer, you would actually see a blinking data light for about a half a second, basically saying that it would be getting written to it. And pretty much concludes our label design aspect of this. So I am going to minimize this, and we're going to move on to the next section, which is going to be our Logix integration. And for this, we're going to open up our Logix program. Now, I already have a head start here and have a Logix program already developed and running, or halfway developed and running, we'll say. But let's say we wanted to add a LinkOS printer. Now, I already have one here in my IO tree so that I can keep my tag structure here. But let's say we wanted to add another one, or in your case, you'd be adding a new your first one. You're going to go to your Ethernet tree. And then open up a new module. My software would work. There we are. So now in this field here, we're going to uncheck our vendors. Sorry, there's a little bit of lag here on my computer. We're going to scroll down. And we're going to check Zebra Technologies. And we can see here that we've got a couple of different options for which modules to select. The EA3600 and FX9600 are both readers. This is a barcode reader, this is a RFID reader, and this is also actually a barcode scanner. So we're going to select the LinkOS printer, and we're going to say create. It's going to pop up once it creates this. It'll pop up with what we want to say. So I'm going to say ZT410. I'm going to say 2 because it's the second one that I'd be doing. And let's say, hypothetically, if I were to give an IP address, let's say it's 192.168.0.250, or not 255, 245. My current printer is 244, so that's why I picked 245. You don't have to change anything here in the module definition right now. Zebra is still at Rev 1 for their AOP for the NetworkConnect firmware, or for the NetworkConnect printers, so you don't have to worry about changing this right now. You can leave this as is. So we will say OK. In this case, I'm actually going to say cancel, but you'd say OK. It would create a module, and you have it pop up down here. So once that pops up, we're going to say close on this, and now we will go and look at our controller tags. So this here's our printer. These are automatically generated from our AOP once you go and select the Zebra printer. You have the input group, which basically defines basically stuff coming back from the printer. So it's an input from the printer to the PLC. And then output is actually where we're going to write stuff to the PLC, or to the printer itself. So as we see here, we have our sequence number, which is going to be what controls when we print. Or format number, which is more like printer enable. So this always gets set to 1, and I actually have logic right now that is writing this to be a 1. If you didn't want it to be set as a 1, you'd have to be set as a 1, but if you didn't want to have it hard-coded in your project or have something written to it constantly that is 1, you could also code it just in here and set it as 1, set it and forget it, basically. Format name, this is what the file name that you're going to recall is. Now, you can store multiple files into the printer at any point in time. Typically, ZPL files, they're basically like text files, so they're really only a couple hundred kilobytes at the most. You have 4 megabytes of user RAM that you can write to, and you also have 64 megabytes of user EEPROM that you can write to. And then we have your variable fields 1 through 5 that you can write to. Important thing to note is that field 1 is the biggest, and we see that that is a 68. Basically, you can have 68 characters written to it from field 1, and then everything else is 20. And then you have your raw parser section, which is basically where you would send raw ZPL data to the printer instead of having it in there. And where that's helpful is if you needed more than 5 variable fields, you could have your 6th, 7th, 8th, 9th, however many variable fields you needed. You'd be able to code those into your parser data and send those to your printer from there. For this demonstration, we don't need them, so we're going to keep them. We're going to keep the parser data empty, and we're just going to use fields 1 through 3 actually. So to get started, let's work on creating some logic that would allow us to print or at least call up the label template. So if we go back to our main routine, what we have here is we've got our, what I have, and again, as I was explaining before, I'm just moving a 1 into the format numbers so that it's enabled. And here we have our format string length, field 1, field 2, field 3, parser data section, and then this is our logic to print. So what I'm actually going to do is I'm going to delete these so that you can get an idea of recreating these. And I'm going to recreate them from scratch. Okay, so under this one, we're going to say we're going to create a new rung here. And I want to insert a CPS instruction, which is a synchronous copy. And our source element is going to be our format string. Now, this string I had created ahead of time. This is just a string that you'd be writing to, let's say you had a SCADA system or really anything that would be controlling or creating a string. So SCADA systems, HMIs, whatever it be, wherever you want the source for this string to be, that's what you would be writing to. So for my format string, we're going to tunnel through it here. We're going to tunnel down into the actual array of synths that are in the string. And we're actually going to select data 0, which is the first synth in the array of, or in the string. And the destination, we're going to copy this into our format name in our AOP, or in our controller tag for it. So we're going to go down, scroll down to our printer output section, format name. We're going to expand format name. And now you have to skip the first 2 bytes of your code here, of the file. And you have to go to the second byte or the second instance of it. And the reason for that is that there is a, it ignores the length part of the printer. And so what you do in a string, it consists of your synths, your array of synths, and then you have your length part. And so it accounts for the 2 bytes that are at the beginning of the string that account for the length and allows you to copy into there. Now I bypass that by going to the array of synth itself and just copying directly from there. You can do whatever you can do it either way, I guess. This is the way that we recommend doing it. So that's how we're going to go. And then the length, we're going to define this length as the length of our format string. So if we expand this, we're going to say format string dot length. And as you can see, this turned gray. So it's happy with this configuration here. And we're going to send it to the PLC. Now, I happen to be online with my PLC. You can develop this completely offline. You don't have to be online with it. I'm just doing it online for demonstration purposes so you guys can see it in real time. So if we go back to our controller tags, what we're going to do is in our format string, we're actually going to enter our format name or our template name. And the first thing you start with is the drive number, which is going to be E for EEPROM, colon. And we called it Zebra VLL, and then you end it with .zpl. Now, .zpl is the file extension. That's what's stored in the printer, and that's what it's stored as in the printer. So you have to call up the entire file name, including the file extension from the printer. So we're going to say apply and OK. Now, if we come down here and we actually go to, not field 1, format name, please. Go to format name. Now that we have that logic in place, it's actually actively copying over what we saw before, or what we entered in up here, into our format name section of the AOP or of the controller tag. So this is what would actively print. And since our format number is set to enable, we actually can print from this. And if we were to generate a file, it will actually print we'll call it a blank. So all of your fixed text fields will print, but your variable text fields, since there's no data being written to up here, your variable text fields will not appear on the label. And so that'll look something like this. Let me just go over and grab it. That'll look something like this. This is the label that's spit out. So as we can see, we've got our fixed text fields and our picture here, but we don't have any information next to our model number or serial number because that hasn't been pulled over yet. So what we're going to do is we're actually going to go and add those parts here. Now, I already have fields 2 and 3 created, but let's go through and step through how to create field 1. We're going to do it in much the same way that we did our format string. We're just going to simply create another rung. Copy our instruction over because we can. And for our format string, instead of it, or for our source string, we're going to change it from format string to our field 1 string. We're going to expand this. And again, we're going to tunnel down to the array of synths and grab the first synth. Now, for the destination, we're going to copy it to the controller tag associated with the printer for field 1. So we're going to minimize this, which is the format name, and we're going to expand field 1. And again, we have to skip the first 2 instances and go to the third or instance 2 of our field 1 in the printer. And we're going to change our length to be field 1 dot length. So now everything's happy here. We see that we have a gray rung instead of, we don't have any red rungs. So we're going to say we're going to finalize edits and let it run. Okay, so we're ready to continue. So if we go to our controller tags, we can scroll up to fields 1, 2, and 3, and we're going to say for field 1, this is going to be, we said it was ZT410 on the label, or in the template file. We actually want it to be something different, so we're going to say ZT411, which is the new generation of the 410. And for our serial number, this is field 2. Let's say we want this to be something other than 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So let's just come up with another 10-digit number. So I'm just going to say 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. Okay, so that's 10-digit serial number. We'll click apply and OK. And for field 3, we said we wanted to do a model number hyphen serial number. So we're going to say 411 hyphen 11111 22222, and we will click apply and OK. So now if we actually scroll down here to our printer output tags, we can see in field 1, we skip the first 2 bytes and we're writing ZT411, which is what we have here. If we close this and open field 2, we have our serial number. And then if we expand field 3, we see that we have our model number hyphen serial number. Okay. So what we got to do now is we're going to create logic to print. Now we can print based on this sequence number here. If you wanted to change this to a 2, it would print and spit out a label. Or we can go through and actually create the routine that would be needed to print. So what we're going to do is in this field here, what we have is we have on rung 6. What I have is basically a simple counter that counts up every single time that you trigger the printer to print. So this print could come from an HMI. It could come automatically from somewhere else in your logic. Wherever it needs to be, it can come from. But basically what we want to do is every single time we click print, this counter is going to go up by 1, and then I'm going to move this accumulated value into my sequence number for the printer. Okay, so I'm going to clear this out here, just so it's set to 0. And if we click print, now right now the sequence number in the printer is set to 1. So if I click print once, it's not going to print because right now the printer is saying I'm already at sequence 1. I need to be different and not 0 to print to sequence or to issue a print. So if I change this and go to 2, it'll spit out a printer, or it'll spit out a label, sorry, and it'll look something like this. Okay. In this case, I actually have a different serial number here for demonstration purposes. I actually put 09876543221 as the serial number instead of what we put previously. But if I want to generate this label, this exact label, actually, I'd be able to just go back into our controller tags here, change this to be this backwards. And same with this guy. And now if we were to print again, oops, sorry, wrong section there. If we were to print again, it will spit out another label and it will look exactly like this. So we would have our ZT411 populated, we have our serial number coming through, and we have our barcode printed here. Now, if I were to scan this with a scanner, or if you have an app on your phone, it would show up as what it is here, and you can actually see underneath of it, we have the string coming through underneath of the barcode. And that concludes our logic segment of this. I am now going to open it up for any questions that come through. So with that, please enter any questions you might have into the comments section, and we will answer them the best that we can.
Thank you, Kevin. I am keeping an eye here for any questions as you have them. And while we wait, I just want to remind you that you can always watch the recording of this virtual lunch and learn. If you want to go back and pause and get some of those QR codes, this will be posted immediately afterward on our YouTube channel under the virtual lunch and learn playlist. And we'll give a couple more seconds here just to see if anyone has any follow-up questions here at the end, in case you've been holding them for the very end. The links to the resources that Kevin talked about are also in the comment section if that is easier for you to just click straight through. they will be listed there and available in the recorded version as well. All right, we don't have any questions at this time, so I want to thank our viewers for joining us today. Thank you, Kevin, for a really great presentation, and Michael for being our resource out in the comments section. I want to remind you to please subscribe to the McNaughton-McKay YouTube channel for more industry content like this. And as always, join us next week for our next virtual Lunch and Learn. Thank you, everyone. Have a great day.